Okay, in this second part of 2023 WAEC SAC practical on number 2, that is identification of ion. The displacement G here, say Dn, there's number of series of cylinders that are going to be taken in this serial number of candidates. That's what N is. G now is ammonium trioxocarbonate form. Okay? Whose formula is NH4 2CO3. Okay, so if you are new in this video, or you are a chemistry student but you don't understand how this part works, I'll just explain it in a few minutes before we now start with the identification of ions. This year's Atlantic B students should be very lucky, okay, because they just have one particular salt and then one particular ion to test, or gases to identify, and that is all. Okay, so looking at this now, if you break this salt into two, you're going to be testing for this ammonia gas and then C. Okay, so we break up this salt, you are testing for this and this, that's all. Okay, the reagents that will match with this will be this, okay, plus heat to hear this smell of this gas. The reagent to confirm this, to take this, is this. Okay, and then this gas will be evolved. Okay, writing the chemical equation normally with this, supposing we want to react this supposedly, this with this plus heat. Okay, so what's going to come out here? Okay, what are we going to do here? Of course, water just needs to come out here, just HO, 1H. We have H2O, okay, and then remember that the gas is produced, and then sodium carbonate is also produced. Okay, so what you need to do is to just balance the equation thing to go here, because this let's be balanced. And how many H do you have here? You have 8, 9, 10. Okay, you only have okay, you need to balance this 2, 6, 7, 8. I think it's balanced now. Okay, so this is what you have. So interestingly, the reaction is just to identify ammonia gas. So at that point, you start to hear a pungent smell. A pungent smell. Okay, that's what you see. So this is what you see maybe in the first instance. Maybe this could be solid, okay, or they may ask you to add a certain volume of distilled water to it before adding this. I don't know any way it goes. This may be solid, this may be aqueous. Okay, this is gas, but the moment the gas is involved, so it's gas will be gas, so it's going off. So what appears to remain is just this, and maybe part of this remaining. But they would like you to test the gas that is involved. Okay, more than this gas is going off, you ask to test this particular gas. Immediately it is involved, maybe the gas plus a comp HCl on a glass rod. Okay, the moment this thing happens, the moment these two combines, you see a dense white smoke or a dense white film forming. That white dense film is as a result of this ammonium chloride. Okay, this is the confirmatory test that the gas is ammonium. Okay, and the same reaction, in the same test tube, they may ask you to add HCl. So that means if you add HCl, that means you want to exactly know if gas carbon 4 that will be evolved from this. So if you have in the same test tube, add HCl, the same test tube. So you will have now sodium chloride being formed, H2O coming out again, and then CO2 afterwards. Okay, the gas formed does not smell. It's colorless and it's also odorless. Okay, just like this gas is alkaline, this gas here is acidic. Then how do you confirm that this gas is CO2? Just like we have confirmed here that this gas is ammonia by passing the gas over this HCl. Seeing this means that ammonia gas is confirmed. How then do you confirm this gas? Okay, we confirm the gas by reacting with lime water, calcium hydroxide, which is colorless. The moment we see a cloudy or a milkiness appearing, that means the milkiness is due to formation of this plus water. That is the reason why there is a milky color coming out. But the milkiness will stand to go off or disappear if you excessively allow the gas to enter. So the gas is not, it doesn't produce any odor, just give out odorless, colorless, but confirm it by passing it over lime water. Lime water, which unfortunately goes to milkiness due to formation of this. But the milkiness will start to disappear on excess bubble on the gas due to formation of this, which is soluble in water. Okay, so in this case, the test. Or we are looking at a case scenario where we want the salts to first be dissolved in water, then divide into two. Okay? Divide into two. Suppose this is a test tube. You are asked to add some small sample, just as small as this, and then add about 10 cm of this water. Then shake to make sure that every part of this at the bottom, to see if all will dissolve. Of course, all will dissolve because the salt is soluble. All carbonate salts are insoluble. Those of ammonium is soluble, so it will all dissolve. So right here, you have that salt dissolves. Then the solution is colorless. You must see the color of the solution after dissolution. So now, in here, you're going to divide this into two. Let me divide into two. Okay? Let's see the first part, which is all I'm testing for CO2. I want to identify CO2. So that means I will in here add, so if I'm to identify CO2, that means here will be CO3, 2 minus. Okay? So in here, I will add HCl, which bring out this. So in the next part, to test for this, okay, which we bring. So we confirm this from this, confirm this from this. That's the only simple test we're going to carry out in number 2. And then we'll draw the table. Let's give the table and then make sure this is represented. So I'm going to put up the table now. All this will be written this way. Test, observation, inference. Okay. Okay, now we interpret your question here, but no mark will be given here. So the marks will be here and here. If here is wrong, you will not get it here. Okay. The first statement you will see in that question will be credit will be awarded or credit will be given if the instruction is strictly adhered by the student. This part of chemistry is one part that is very technical. Its technicality is why most students fail this part. It can be as simple as possible, but you tend to lose mark that is ought not to be used. What am I trying to say here? You will interpret your question. You will see where they say that G is an inorganic salt. Carry out test on G and record your observation and conclusion of each test carried out. Okay, good. You should put up the table. Then now I'm going to see question number 2AI. We'll start with 2AI. That 2AI will be put some sample of G in a boiling or test tube and add about 10 cm of distilled water and shake thoroughly. Okay? And then to the solution, you test it with an indicator paper, that is litmus paper, to see if the solution of that salt is either it is acidic or it is basic. That will be that part. Okay? So how I will do that is to say, since that salt is G, or write G here, the state of matter of G is still solid. You're going to see a white powder salt. Okay? Cg, Cs, that's the state of the matter of G. G solid plus added distilled water. This is the distilled water plus stir or shake. Shake thoroughly. Shake thoroughly, I mentioned thoroughly. Okay. Let's see the words that's the most often seen they use. What's going to be our observation? Make sure the observation is as brief as possible. So if G dissolves, you say it dissolves. If G does not dissolve, you say it does not dissolve. But basically, salt will dissolve. So right here, dissolves, dissolves, dissolves. Okay? Dissolves, comma, gives colorless solution. There are two things I state here. It dissolves, and at the same time, solution is very not colored. What will be my inference? Because since it dissolves, G is a soluble salt. G is a soluble salt. I write it here. G is a soluble salt. G is a soluble salt. Or G is soluble in water. Or I can say soluble salt of transition metal ion is absent because solution is not colored. But this is most appropriate. Okay. The next question will be to the G solution now, which is going to come in here. Solution G. Solution G plus litmus paper. Okay, what is going to be its effect on litmus paper? No effects. No effects on blue and red litmus paper. So what's going to be my inference? I say that G, solution G is neutral. Okay, that will be the end of that part of the question. Okay. The second part, you will see where they ask to divide what you have here, the solutions you have in 2AI above, into portions. Okay? Into portions. Then to the first portion, let's say first portion of this, if you see first portion from 2AI above plus dilute HCl. That means you have to identify carbonates. Okay? You have to identify carbonates by testing for CO2. So once you add this HCl, what happens? You now see that effervescence occurs. This is the first thing you see. You kind of see bubbles coming out from the liquid. That's what effervescence means. Effervescence occurs, comma, or colon. Colorless and colorless, comma, odorless gas evolved, comma, turns wet indicator, wet litmus, let's use litmus paper, faint red, okay, this is what it is. But on the second analysis, you will ask to add its lime water. So when the gas is evolving, after knowing this, observing this, ask to pass the gas over lime water. What happened to lime water? Now, turns lime water milky or cloudy. They may ask to bubble it in excess, which, comma, disappears. This appears on excess bubbling of gas to excess bubbling of gas turns into a clear solution. Okay, that is if they ask it, but if they don't just come stop here, turns lime water milky or cloud, you can stop there. But if they say bubble it in the excess, that means that starts with this, disappears, and excess bubbling of gas turns into clear solution. That's what happens. Then come here and first of all, gas was able to turn faint. But before the gas, because of this 80%, you cannot see that CO2 from CO3 2 minus or HCO3 minus present. And then from where it turns this, you cannot say gas is acidic. Must make sure it's common. Okay. Then where it turns lime water milky, you can now come here and then say that CO3 2 minus or HCO3 2 minus confirmed. That's confirmed where it turns lime water milky. So this on that test. Okay. That is on that part. Then on the other part of the question, which will be, this question is going to be AI, or I don't know what I mean. So this one could be now 2BI. Okay? I'll just do the second portion. from 2AI above plus NaOH plus heat. Okay, so what's going to be inference? Gas was evolved. Gas was evolved. Colorless pungent smell, tongues, wet, red litmus paper, blue. Okay, you should know that you can write alkaline gas. Yes, any gas that does that is an alkaline. Okay, that's what happened. Okay, so what is going to be my inference here? So that means here NH3 from NH4 plus present. Okay, but this is not going to be the end of it, because you must confirm it if it's actually NH4. Or how do you confirm it? So what you have here, you pass it over line water. Maybe I'm going to put that in quickly. That's the continuation of this. So from here could be 2BII, gas from 2BI above plus conc ACL on a glass rod brought close to the mouth of test tube. Okay, so that is what the interpretation will be. Supposing in the question, the second portion, you should add NOH and heat, and in the II, they say a glass rod with conc ACL, bring it close to the mouth of the where the NH3 is evolving, and what will you observe? Simply say a dense white film is formed. Just this. And what will you have here? NH4 plus confirmed. So this is what to do. And that is the end of the analysis. Thank you for watching.